I want to thank one of our bronze sponsor, Reversec, for sponsoring this conference. Nothing is possible without the sponsor, so thank you. Now, the next speaker is someone who was very helpful for me for my cloud security journey a couple of years ago. And now I'm lucky enough to work with him, so please welcome on stage the terror of the cloud providers, Nick Frichette.
Good afternoon, everyone. Thank you so much for being here. In this session, we're going to be taking a look at AWS access key honey tokens. We're going to talk a bit about why they're so effective as a detection tool, cover the different types, the pros and cons of each, as well as take a look at some scenarios where you can determine if an access key is a honey token without actually triggering it. My goal today is to give you sort of a technical understanding of how access key honey tokens work. That way, regardless of whatever vendor you choose, whatever open source project you deploy, or maybe you're entirely rolling your own, I hope I can help build upon your program and help you cover some edge cases you may not have considered before. Before we get started, though, I think it's worth reminding ourselves that threat actors love AWS access keys. One of the primary ways that threat actors gain initial access in AWS environments is leaked credentials. Attackers know they can use these to get initial access, move laterally, steal resources, do ransomware, and so much more. One particularly upsetting statistic comes to us from AWS's own customer incident response team, who stated that in 66% of incidents, the initial access method was leaked access keys. And in perhaps a slightly even more upsetting case, 20% of those came from root credentials. So we know threat actors are constantly looking for these credentials. What if we weaponized that behavior against those threat actors? That's the idea of a honey token, intentionally sprinkling credentials around your environment, storing them in Git, putting them in scripts and network shares, putting them on devices and servers with the intention of laying a trap. Once an attacker uses them, that'll send an alert, and you can then go and respond to it. If you'd like a real-world scenario of this actually being incredibly helpful in an intrusion, just a few weeks ago, Grafana released a blog post covering their situation and how they actually use canary tokens to help do that. So I think it's safe to say that honey tokens are incredibly powerful and incredibly helpful at catching adversaries, but there's a couple things that you should know that you may not have heard before. To get us started, I'd like to talk a little bit about the different types of honey tokens. The first is what I will loosely define as CloudTrail-based honey tokens. These are sort of like the traditional tried and true methods. You might be familiar with projects like Spacecraft from back in the day, as well as more modern solutions like GitGuardian's GG Canary. In addition, from speaking to a few folks from around the con, it sounds like one common sort of implementation of this is to create like a SIM rule looking for specific access keys. That would also, I would classify as a CloudTrail-based honey token. Now, the specifics on how this works will depend on that implementation, but the general idea is create an IAM user, create an access key, and then through some automation, stare at CloudTrail looking for an occurrence of that key. If it shows up, you know somebody used the key, and you should go alert and react to that incident. CloudTrail has a lot of benefits for this use case. You get all that great observability data. You know the IP address, the user agent, the service, and the operation that they're trying to perform. And in addition, these days, CloudTrail's pretty quick. Long gone are the days of waiting like 15 to 20 minutes for the logs to actually show up. And this makes it sort of a preferred mechanism for a honey token. Unfortunately, though, if you use CloudTrail as your alerting mechanism, it's really important to know that not everything logs to CloudTrail. And to be clear, this is not a passive-aggressive CloudTrail bypass joke. No, there's just stuff that doesn't show up in CloudTrail. I have a few examples on the slides here. And of course, that's not to mention things like data events that you have to configure, set up, do advanced event selectors, and so on. Now, you might say, well, Nick, who cares? Why do we care if it doesn't show up in CloudTrail? Well, the reason is that, unfortunately, a number of providers end up leaving little tells inside the ARN of that calling identity. See, when you perform an API operation, AWS is pretty helpful. They'll give you pretty verbose error messages telling you what the problem is. And like I said, unfortunately, some providers actually put in particular names or descriptors that tell you it's a honey token. So for a threat actor who has found access keys, they can take them, perform an operation that doesn't log to CloudTrail, and then test if that is a honey token. Spencer Geetson did this back in the day with a project called Spacecrab. Unfortunately, they, by default, included a path called Spacecrab in their users, and so that made it very easy to identify. Unfortunately, for a more modern example, history has repeated itself. GateGuardian's GG Canary does the exact same thing. The path, by default, is GG Canary. You perform an operation that doesn't log to CloudTrail, and you can tell if it's a honey token. Specific to that one, though, worth noting, since it is self-hosted and it's literally just a bunch of Terraform, you can change that, but you have to know that it's something you should change to get rid of it. And in another example that there's a little bit of an asterisk for, we also have Thinks Canary's Canary tokens, which includes canarytokens.com in the name, giving away that it's a honey token. So if you are self-hosting, rolling your own, or using a provider, it's worth checking what the name of that user is and if that gives it away, because combined with it being a CloudTrail-based token, you could just completely nullify any usefulness that it provides. But I did say there was a little bit of an asterisk, and that takes us into the second option, the second category of honey tokens, and that is what I'll refer to as the credential report tokens. Long story short, Thinks Canary sort of looked upon everything I described previously and needed to come up with a way to try and mitigate somebody doing that to avoid detection. And so they implemented what they refer to as a safety net. Through somewhat of a, it's a small world, turns out this advice came from Scott. And if you don't recognize the man on the screen, I believe this is what Scott looks like underneath the beard. Now, Scott gave Thinks some really good advice, and that was that they should use the credential report as a backup mechanism for alerting when tokens have been used. If you're not familiar with the credential report, I don't blame you. It's kind of a legacy feature at this point. The way it works is the credential report is a CSV file you can create every 4 hours. And it includes, as the name implies, information about credentials in your environment. And the particular column that we care about is the access key last used date. And the reason for that is what we can do is set up automation to run every 4 hours, looking to see if that column or that particular row has changed. If it has, we know that that token has been used, and we can go react to that behavior. And so you might say, well, Nick, this is cool, but like, what does this give us that CloudTrail-based honey tokens don't? Well, it's important to know, and the reason it's a really good idea, is the credential report-based honey tokens will be updated or will alert on APIs that log to CloudTrail. It will also update or alert on things that don't log to CloudTrail. So for instance, data events, doesn't matter what you have configured, doesn't matter if you have advanced event selectors, doesn't matter if you have nothing at all. If you perform a data event, it's going to show up in the credential report. CloudTrail bypasses, this is the time for the passive-aggressive CloudTrail bypass joke. Because even if you find a literal vulnerability in AWS, allowing you to access resources, make changes, delete things completely silently, it still shows up in the credential report. Next thing, non-production endpoints. Long story short, there are thousands of API endpoints available over the internet you can authenticate against using normal creds. Take, for example, simba-gamma.usc2.api.aws. If that's gibberish, it is. When it was active, this endpoint was associated with the FSX service. And in this screenshot, you can see we're performing FSX describe backups. You can see the error message telling us that it is a Thinks Canary token. And even though this didn't log to CloudTrail, and could be used for permission enumeration, turns out it does still show up in the credential report. And of course, undocumented APIs, exact same story. Doesn't matter what weird undocumented APIs you find, doesn't matter if it doesn't show up in Botacore, regardless, it will still show up in that credential report. So for this reason, the credential report is an incredibly resilient form of detecting when access keys are used. There doesn't appear to be any way that you can use the keys without that appearing inside of the credential report. So that's much more resilient than something like CloudTrail. Now, unfortunately, not everything in life is perfect, and this is no different. There are some drawbacks to this particular method. The first is, as I mentioned before, it can be incredibly slow. If that CSV is generated every 4 hours and you catch it at the wrong time in the automation, 4 hours is quite a long time for a threat actor to be aware that they've just been burned. Remember, some tokens actually include their name in them. So if you are using, say, Thinks Canary tokens, you try to run an API operation, you see, oh, it's a honey token. Well, what should I do now? How about we start destroying things, encrypting things, doing some little ransomware? That might give a heads up to the adversary that, hey, I need to move now. And even if we say, take an average, maybe 2 hours, that's still a very long time for a threat actor to try and do other things in the environment. The other downside is because you're using the credential report, you lose out on all that visibility. You actually don't get to know what IP address called it, the user agent, or even the specific operation. As goofy as it sounds, if this triggers, all you know is somebody used the keys. You know the time and you know the service, and that's it. So you do lose out on a lot of that visibility that would otherwise be incredibly useful to React. Finally, I did want to mention sort of a third way to go about this. From evaluating a couple vendors and looking at open source projects, I haven't seen anybody implement this, but I wanted to mention it because I do think it is a notable improvement on the second option. And shout out to a colleague of mine, Sam, for giving me this idea. We were chatting about the safety net and how it worked, what its limitations were, and he asked a really good question, which was, is that the same thing as IAM get access key last used? And as it turns out, yes. Or at the very least, it appears to be the exact same thing. If you're not familiar, IAM get access key last used tells you the last time an access key was used. And the output, if we take a look at an example, looks pretty similar to what we saw in the credential report. In particular, that last used date and that service name. So what this enables you to do is you can run this API as much as you want. There is no arbitrary 4-hour time limit. So you can run this automation, say, every 5 minutes, every 6 minutes, constantly checking if that last used date has been changed, and if it has, alert. This gives you the benefit that it is substantially quicker than the credential report, and can be a much more effective way to go about it. Unfortunately, again, you do lose out on like the IP address and the user agent, all that useful information. But there's nothing saying you can't combine these methods. They're not mutually exclusive, and indeed, you probably should. CloudTrail makes it effective to get all that additional information, the IP address, what the operation is, and this will catch most unsophisticated threat actors. Access key last used can be useful to catch threat actors who are trying to evade detection, who are trying not to leave a trace. And these two combined can be really effective. Now, you might ask, can you fingerprint? And by fingerprint, I mean determine if an access key is a honey token without triggering it for options 2 and 3. And the short answer is yes, but it tends to be very, very situational and relies upon you knowing a little bit extra about the environment or the situation. So in terms of how you would do this, it's worth knowing that if you have an access key, you also have the account ID associated with it. There's 2 ways to do this. The first is there's an API for it. STS get access key info. You pass the access key, you get an account ID. Second method is, thanks to some research from Eden Steele and Tal Berry, you can actually decode it. That access key actually includes the account ID encoded within, and you can derive that value completely offline without having to make any API requests. Once you have the account ID, this can be potentially useful to determine if it belongs to a known honey token provider. So for a real-world example of this, this is actually how Trufflehog is able to determine if a access key is a Thinks Canary token without actually triggering it or sending off an alert. They essentially have sort of a list of all the like the free tier Canary token AWS account IDs, and they just refer to that list and check if it's in there. This can be a somewhat effective method depending on the provider. It relies on you sort of having that information, either getting it through open source, sort of like this, or through some other means. If you are self-hosting those tokens, that might sort of mitigate this risk in the sense that if it's your account, it can't really be on some big public list of known honey token providers. If you're a pen tester or a red teamer, you could be aware of what account IDs are associated with those and then avoid those tokens. If that's considered cheating, that's between you and your SOC. I'll let you figure that out. A second method comes to us from a researcher by the name of Rad Kawar, who took sort of a side channel approach to it. Similar to what I described before, he knew you could derive an account ID from an access key. And with that information, he also knew that Thinks Canary's infrastructure, at least part of it, is actually open source. And so once he had an account ID, he figured he could enumerate some resources cross-account, things like roles, users, and S3 buckets. So if he, say, came upon an access key, gets that account ID, he can then go check for the existence of AWS token role inside that account, or a particularly named S3 bucket. And that could give away if it was a Thinks Canary token or if it wasn't. Now, if you use Thinks Canary, worth knowing, they have since mitigated this. In response to that research, they actually did implement some changes, and now they actually have like random modifiers at the end, so you can't guess the existence of it. But worth being aware that this technique can work and may be useful against other providers or potentially like open source projects or self-hosted tokens. So with all that out of the way, I want to stress that I think honey tokens are incredibly powerful detection tools, and we haven't even had the opportunity to cover things like honey resources, things like deploying S3 buckets, RDS databases, DynamoDB tables. CloudTrail-based honey tokens can be really effective, but they can miss some operations, and in some cases actually give away that they are honey tokens. Using the Credential report or IAM get access key last used as an extra mechanism can be really effective to mitigate that. You want to be really mindful of how you name your honey tokens. Don't put the word canary or honey token in the name. If you use a deception tech provider, test it out, see what they're called, and if there's something that you can reliably sort of identify. And then finally, on paper, it's true that like any honey token can be defeated through some means. Side channels are always a risk, but they tend to be very situational and aren't something that realistically in most circumstances can be repeated. Self-hosting your own tokens or going with a provider that allows you to create tokens in your own environment may be sort of like an extra best defense against that type of attack. And with that, thank you all so much. If you have any questions, I'd be happy to answer them. You can find more of our research at securitylabs.datadoghq.com. And thanks again.
Thank you, Nick. Any question in the room?
Hi, great talk.
Thank you.
So I had a question. Do you have any speculation on how, I guess, like the get access key last used is implemented or checking? It's interesting that even if you find like an undocumented API, it still somehow knows the service. Mm-hmm. Do you have any idea of like maybe how that works behind the scenes?
So that's a fantastic question. I don't have any insider info, but I think what's interesting is if you observe it from the outside, it appears, we did a lot of research on non-production endpoints, taking production creds and then going to like developers' individual like API endpoints, and they like work. It appears that like the authorization or authentication component of IEM is global. It runs against everything in that partition. And so that's on the one hand why we can call those APIs, but also why they get logged since there is that one centralized thing. That's my assumption, at least. I've not had any internal information for sure.
Hi. In your personal experience, what team is responsible for setting this up, and how many people do you inform about the honey token? Like, do you have some random infragment by accident being like, oh, what's this? Let me try that out, and your canary goes off. Like, how widespread do you keep this canary in the company to make sure it actually works?
Yeah, I mean, it really depends on sort of the scale you're operating at. I think in a small organization like a startup, just having like 1 or 2 people aware tends to be pretty effective. It's sort of almost like a bell curve of like, as you get bigger, you need more people to know, but then if you get too big, nobody's gonna pay attention or like be aware that they exist. You do always run the risk of there being false positives by some nosy DevOps engineer being like, found access keys, what's up with that? And they're running them. But in general, I think the best places to put them are sort of like tucked away, hidden, in Git commit histories, on individual machines. That way you're mitigating the risk that somebody stumbles upon them unless they are doing a little bit of a recon or enumeration in the environment. Yeah.
Great talk. Thank you. Thank you for the talk.
Thank you.
The question I have is, did you consider how hard it would be to make credentials that would actually allow all the non-logged operations to kind of keep attacker in and then only do access denied on those that are logged?
Yeah, I mean, so as a research organization, we've done / talked about creating like honeypots for threat actors, like leaking credentials that have a little bit of access, and then seeing what they do with it. So I think there's probably other research organizations in the audience who've done similar things. The disappointing thing is, in my experience, they do what you would expect, which is try to do crypto mining, try to do like SES stuff. So haven't seen anything novel through that, but maybe someday.
Any more questions?
I found the sort of cat and mouse game between honey tokens and those who'd use them fascinating. Mm-hmm. What do you think about like more advanced analytics, potentially putting LLMs in place to look at the context of where honey tokens came from to try to like give attackers more context as to whether that's a honey token or not?
Yeah, I mean, I think, when I was previously working as a pen tester, sometimes some honey tokens are like canaries of not just AWS, but various API keys and whatnot, can be a little bit suspicious or odd. Like, if you put it on an EC2 instance, why is it sitting there when it has like an instance profile? Some of those can be kind of a giveaway. I think it really sort of just, it sort of is this gamble of like, it could be real, and it could give me something good, or I could get caught. So it really is sort of that making your best judgment when you can.
Maybe one last question. Okay, so the break will be until 3:15, and there's a feedback form on your way out, so please fill it in for this talk and all of the others, and thank you.
Right. Thanks, everyone.
Thank you, Nick.